All right. Hello and welcome, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for being here today. My name is Sarah Alspawn. I will be your webinar host. I'm coming to you live from Cincinnati, Ohio, here in the U.S. Our topic today, asset performance excellence for smart energy and utilities. Before we begin, I just want to go over a few quick housekeeping items regarding the interface. At the bottom of your browser in the center of your screen, you will see icons in a widget dock, and these are the interactive tools that you can use throughout the webinar. You can minimize, maximize, and scale each widget to customize your viewing experience. I would like to call your attention to the Q&A widget. The Q&A Ask Questions window should be open and is located on the left-hand side of your screen. You are encouraged to submit questions to the presenter throughout the webinar using this widget. Do know that your question will disappear when you submit it, but we'll still see it just fine. And your questions will be saved and answered during the live Q&A at the end or offline after the webinar. On the far right of the widget panel, you will see the Help widget. If you are experiencing any technical issues, please click on that for assistance. But do know that a quick refresh of your browser will solve most issues, so definitely be sure to give that a try first. And finally, this presentation is being recorded and you will receive a link to view it in a follow-up email. All right, a little bit about Siemens Digital Industries software. We are a business unit of Siemens Digital Industries, a leading global provider of software and services for engineering, manufacturing, and electronic design. Many of the world's leading companies place their trust in our know-how and our accelerator portfolio to drive digital transformation and realize their important innovations. And I would like to welcome and introduce our speakers today. With us, we have John Lusty, John Nixon, and Fabio Sala. I will briefly read from their bios here and then quickly turn things over to them. You can also find their bios in the top left-hand corner in the bios widget. You can just expand the little blue arrow next to their name at any time to read more. Fabio is an experienced Industry 4.0 thought leader with a native addiction to identifying, evaluating, and designing digital transformation roadmaps and solutions. Fabio has been working in the manufacturing technology space for over 25 years, managing and delivering IT products, projects, programs, and teams to market leaders in the automotive, aerospace and defense, piece part manufacturing, heavy machinery, and consumer goods sectors. His areas of focus include business process analysis, manufacturing execution systems, product lifecycle management, quality management, Internet of Things, simulation, advanced data analytics, and artificial intelligence-driven manufacturing. After almost 20 years with Siemens, the last 10 spent as Director of Director of Manufacturing Operations Management, Delivery Services, Fabio joined the Engineering USA team as Vice President of Industries Excellence USA, leading both operations and business development in North America. In this role, he plays an essential role in the definition and execution of the Industries Excellence Global Division's strategy for the engineering group. Originally from Italy, Fabio lives in Boston with his family. John Nixon is the Energy and Utilities Global Strategy Lead for Siemens Digital Industries Software. John has worked in energy and utilities for over 28 years. John created multiple energy and technology startups, leading business development in China, Romania, Panama, and the USA. John has also led large greenfield and brownfield projects with oil and mining supermajors in Canada and China, and spearheaded pipeline asset integrity programs in the US and Mexico. In addition to this, John holds patents for pipelining technology and has been a board member for multiple technology firms and university R&D associations. John was an officer in the U.S. Army and holds a BS in civil engineering from Texas A&M University. John Lusty is the Energy and Utilities Industry Marketing Lead for Siemens Digital Industries Software. He began his career with Dow Chemical and later Nalco Chemical in technical sales as a steam and cooling water chemistry specialist in engineering and chemical plants. In 2000, John moved to the software industry, holding management positions at Allegro Development and Bentley Systems. In 2010, John joined Siemens with roles in enterprise sales, industry solutions, and now global industry marketing. John holds a Bachelor of Science in Earth Science from the University of Guelph. All right. Well, welcome. We're very excited to have all three of you here today. John Nixon, I know you're going to kick things off for us here, so I will go ahead and turn things over to you. Welcome.
And let me verify you can hear me.
We can hear you loud and clear. Thank you.
Okay, wonderful, wonderful. Okay, well, unfortunately, I will not have my camera on today. We had a little bit of technical difficulty this morning, but hey, that's the world of the post-pandemic world we live in. We're all Zooming all the time and relying on technology. So let's talk about some megatrends that are going on here in asset-intensive industries. I come from energy, and so I'm surrounded by this asset-intensive world. And we're all seeing a growing volume and complexity of the data associated with these assets. And, the other trends that we're seeing closely married to that is this optimization of performance and the planned outages that go with these asset-intensive industries. And we're all feeling the pressure and the focus and the opportunity to drive more sustainability in this world. And when you look at these challenges, when you look at that sheer complexity and that sheer burden that we have, we are truly awash in data now. And so that's the real challenge. I've been in this industry long enough to know that it was a challenge to gather the data. You'd send people in the field, you'd do inspection and test, you'd gather that data, but then you had a lot of re-entry, a lot of introduction of human error in the data and so forth. We've kind of overcome that because everything has been sensorized, right? If that's a word, it's everywhere that we're gathering data now. So now we have the other problem is we've got a tremendous load on us, and we've got to sort through that. And so there is a demand for better planning and analysis based on that sea of data. And we want to drive to reducing nonconformance, and we want to navigate the standards. So when we have all of this sustainability, we have all these increasing requirements, we want to be able to make sure that we adhere to them again. But how do we do that with all of this volume of data? And then as a proxy to that, look at some of what we're seeing in the market, right? Enterprise IoT market as a proxy for the capturing of this data. You look forward. We think we have a lot of data today. It's only going to grow over time. So here we are. We're in an asset-intensive industry. It's extremely complex. There's an immense amount of data coming at us, and the research shows us that we're moving in a direction where that's not going to let up, and it's only going to become more and more. And, what's interesting is if you take a step back and look at the even broader picture, we are producing, and I think I read a quote somewhere that more data has been produced in the last 2 years as a species than we've had our entire time on the planet. We're moving to a volume that if we don't prepare ourselves today, it's going to become overwhelming to sort through and to gain insights from. But there's opportunities here. So there's real opportunities here to drive better strategies. There's better opportunities to optimize the productivity around these assets, but it's going to take a lot of investment in digital technologies and connectivity, and most importantly, the ability to actually move through and do timely analytics. And here's what excites me about our partnership with engineering and the fact that we have Fabio on today, is they've come up with a suite of solutions based on our technologies here at Siemens that I'm real excited about, that he's going to talk about today, that address the fact that with this ever-increasing complexity and volume of data, there's an ability to actually move through and understand the insights that we should be gleaning from that. And we've got real-world cases of success now in our partnership with engineering that we'll be able to talk about today. And, when you look at the different use cases, again, if we go back and we look at our research here, remote asset monitoring, IoT-based process automation, and remote asset monitoring and control, those top 3 out of the top 10 here, I want you to pay special attention to that because there's some great solutions that Fabio is going to be speaking to that really address what our research shows are the real challenges and the real opportunities that people are seeking solutions for. And as we go through today's conversation, as we think about your challenges, as we think about what the market's looking at, ask yourself this question: where are you or your firm today in your journey through this complexity, through this volume that's growing? Are you a reactive organization? Are you involved in a preventative mindset? Do you believe that you're really in a condition-based monitoring or more proactive environment? Or do you feel like you've reached the zenith and you're fully predictive and fully prescriptive? You know, in the 30 years I've been in the business, I would say today most organizations are at best probably preventative. They're gathering a lot of data. They've got some rules of thumb. They've got some proven practices that they use. But for the most part, a true proactive condition-based monitoring capability is something I'm starting to see customers move into, but I tend to find them defaulting back to more of a preventative mode going forward. So, John Lusby, you know, as we're talking about all of this, and as we're thinking through the challenges and so forth, what are your thoughts?
No, I think you're right. The only thing I would add, John, is that, you know, given the challenges that we're seeing in the energy industry between the crazy changes in demand, we're running the power generation and the refining complexes really hard. Everything that we can do to bring the consistency of supply and the reliability of our assets to the highest level possible is going to help, because at the same time, the industry is working towards increasing its level of sustainability by reducing emissions. So there's really two big pinchers that the industry is in between right now. So, you know, the data-driven approach that yourself and Fabio are talking about, it couldn't be more timely.
Yeah, and you know what? You could even say this is a trend above all trends. This drive for an energy transition that our species is experiencing right now. Not only do you have to keep current assets, your brownfield assets, continuing to function at a hard pace right now, as you say. You know, we're post-pandemic. We're pushing everything to the limit. We postponed all of the investment that we needed in maintenance projects. So you're really stretching things out. The price of gas, the price of gasoline, the price of oil, everything is stressing the system. And so the demand for insights to ensure that we don't have an unscheduled release or an emission or a leak or, you know, an explosion or some other mishap, the demand on our complexity for existing systems, you now add a layer on top of that of now the renewables, the wind farms, the solar farms, the offshore, the wave technologies. The list goes on and on about what we're putting as layers of other energy generation. It can be truly overwhelming if you look at it from a global perspective when it comes to complexity, and if you're a customer, especially with a global and worldwide footprint.
Yeah. You know, and the other thing we haven't seen yet, or is only starting to emerge as regulatory and policy frameworks around the world start to get put into place, not necessarily aligned. You know, we're focused here on using deep engineering to run our facilities more, more reliably, more consistently. We're at some point there's going to be a requirement for a tremendous amount of data to support the deep compliance requirements that are going to emerge in this system, which, you know, for the work that Engineering USA is doing, I think is going to be a tremendous contributor in terms of being able to surface the data that's going to be required to populate whatever the compliance regime looks like going forward, which again, I don't think we've seen yet. Too much is still changing. So,
right. With that, I think that's a great lead in. I really want to get Fabio in front of everybody here to start talking about those tools and processes. I got to tell you, I've never been more excited about a partner. Engineering is such a great source of innovation, and what we've seen them develop over the last several years in the face of all this complexity and unknown, as you said, John, is exciting. So Fabio.
Yep.
Would love to hand over to you right now, and let's take a deep look at what you've got there at engineering.
Thank you, John and John. This is Fabio Sala, and I'm Vice President of Industry Excellence for Engineering Group. And today I'm talking about asset performance management. So this is a story of data. So we want to discuss how we are leveraging data with the solution in order to really increase the performance of the asset. So the focus is really of the story today is really around data and the increasing of performance. No? So today a lot of companies are already on the journey of digitalization. And a lot of data today present in the system. There are a lot of technology that are able to collect data and to represent data. So we are probably now at the point where we need to ask ourselves, okay, how do we use all these data to support the decision process? So how we use the data to make smarter decision. So it is really a journey. So a journey of data. So I think that the left part here is describing the current state. So we started from raw data, contextualized, so starting associating this data to manufacturing objects like the day, the shift, my production order, and so on. So building report to define what happened. Already on the market, there are a lot of diagnostic BI tools that can start allowing us to compare data among them. So starting understanding why did it happen. So now we are in the journey, I mean, for the future. I mean, what we need to enable with technology is also support the answer to some question like what will happen and when. So here we are on the predictive space. So when we can start using data to predict the future and what I need to do. So now here we are in machine learning, prescriptive, until reach the point where we have we can use the data and we can use AI to really support automatically the decision process. Also having not only the data supporting the human, but in some cases maybe also substituting in that. No? So today the focus is around asset performance management. And how to increase the performance of my asset falls around this topic. So how I can increase availability, efficiency, the quality of the product I'm producing, how I can minimize the energy consumption or optimize maintenance or optimize operation. So in engineering, we basically create out of our experience a set of standard solution that are around all these topics. So, for example, smart performance is really focusing on optimizing the performance of the asset. Smart predict is more around early warning, predictive maintenance, so how we can now predict when the machine will fail. There are technology today that can support the maintenance process. This is smart maintenance with root cause analysis, condition monitoring, also with tool of collaboration. We are now on the smart collaboration side, so where we use augmented reality for training or for supporting the maintenance operation in order to optimize that. No? Smart monitor is more focused on the quality, so how to improve the process. And the energy, of course, there is a lot of attention today around that. Also, how we can optimize the energy utilization of an asset or be focused on regulation compliance and so on. No? So when I have also an example for smart decisions, so here how we can use advanced techniques. This will be a kind of deep dive for the next webinar of this series, but also I will give you today a kind of introduction how we can use simulation in order to support the decision process as well. So let's start from the first one. So how can I measure the performance of my asset? So this is probably the basics. So here Smart performance is really focused around providing descriptive analytics. This is typically the first step. So how I can start measuring the performance of my asset in terms of availability, utilization, OE, understanding when an asset is down, what is the reason, and so on. So only measuring, here we have a certain level of optimization of the production process and minimizing of this performance. So here really, I mean, an increase overall of asset efficiency, I mean, at least 5% out of the measurement process. This is typically the case. No? Now the next step is, maybe the next question is, how can I predict the failure of my asset? So here we are more in the predictive analytics space. And typically this kind of solution are step by step. There is maybe step one, where the focus is on data, so collecting real time and monitor critical asset reliability measure in order to provide early warning. So start understanding out of the data what are the conditions that can influence the reliability of my system. The step two is really applying now machine learning and predictive out of this data. The goal is to predict the fault detection, start also understanding and classify the asset based on data which are healthy or medium degraded or severely degraded, and so really using data to define the strategy of maintenance of my asset. So here we are in increase of asset availability by 15% is what we experience in this kind of application. Other kind of question we can ask, this is interesting use case, is how can I optimize the energy usage of my asset? And here again, you can go step by step, starting from collecting the data out of the meters and start monitoring them in terms of consumption by line, by machine, by plant, and really building KPIs out of the energy consumption, link them to the total cost of the energy supply, and also start detecting which are the opportunity for start optimizing so the energy usage and so on, no, and so on. So, and also this is also the base for all the initiative of sustainability for reduction of CO2. So to have basically the base of data for all this strategy. Here the step two is really now using the electricity, using the data in order to support the decision process. No? For example, here we have a case where we're basically using AI to decide when to switch to solar. So basically here through data, the idea was monitoring the consumption of energy and also the cost of energy, and switching to solar when the system was predicting that the price of energy was going up. No? So we can also apply, in this case, logic to optimize the decision process. Reduction of 30% energy cost. This was this particular case that was very, very rewarding. Smart Monitor is more focused on how can I optimize my product quality and the manufacturing process performance. So step one here is now monitor and collect data around the process characteristic in real time, start trending values of my type of production that can be continuous, batch, or or even discrete, understanding the deviation, monitoring the data in order to provide alarms and corrective action, and some KPIs like can be yield QA or SPC and so on. So now on the base on this kind of data, the step 2 is now start to understand how to apply a prescriptive analytics. Here the goal is really using analytics in order to understand which is the correlation between my raw material, the process parameter, my asset condition, maybe external condition as well, and the output that is the finished good quality of the product. No? So we can really using AI here to automatically learn out of the data. So building a model that basically relate input and output. And the goal is optimizing the output, so optimizing the quality of the product that I'm producing. So in our plant today, in certain cases, there is a lot of experience in the human, in the operators that knows this kind of correlation. Here we are really using technology to support the decision process and also optimizing in time, in performance, and so on. So this is more focus, again, around the quality aspect of my production. In this case, we provide quality improvement so this is quality ratio from 67 to 93%. Another aspect is around maintenance and collaboration. So how can I optimize the efficacy of my asset intervention? So here we are really using augmented reality to support the maintenance process in order to really optimize the collaboration with the experts that are maybe not on the field, supporting the operator with instruction, with augmented reality instruction step by step. So it's really using technology to extend the remote collaboration, the integration of the action on the field with the real-time data, with the goal to really optimize the maintenance process and be sure we have on the field the best technician ever, every time. No? So, and this, of course, is also another angle of supporting high performance in my maintenance process. So we experience here increase of maintenance efficiency by 15%, only supporting this operation. The last case is interesting. I want to describe this use case to you. This is a wind turbine farm. So, and the challenge was optimize the performance and also the part of the crews that needs to go from one windmill to another one to support the maintenance process. So it's really a problem of optimizing the path, not based on external condition. So in this example, we really use a simulation. So what you see here is really a simulation model that simulate the maintenance crew, the wind turbines, and all the possible events that can happen. So we are using simulation in order to train an AI agent with the goal to optimize the path, optimize the strategy of my maintenance process. So the result of that was really a reduction of maintenance cost by 30%. So really using the simulation in order to generate enough data in order to create an optimal model for maintenance. So This is what we call smart decision. So really using AI and simulation to support the decision process. In the next webinars of this series, we keep going and let me say, explaining to you guys some other example of this kind. Okay, here, in engineering we have an holistic approach to asset excellence. So for us, the platform based on Siemens technology is really the base for creating data model, what-if scenario model, and decision model in order to support this journey. So starting from descriptive and diagnostic and still having the human taking the decision, but also having the possibility and the tool not to start building what-if scenarios and prediction and support the decision process. So reaching the prescriptive level till reaching the level where, we can automatically automatize the decision. So a pure prescriptive approach. A couple of words on us. So we are engineering, so we are a global company of consulting and system integration in the Industry 4.0 space. So I'm part and responsible of Industry Excellence for US. This is a global organization that presents 1,000 consultants all over the world supporting the implementation of Industry 4.0 solution. With Siemens, we have a long-standing partnership, and we're really covering, let me say, all the offering of Industry 4.0. And what I introduced to you guys today is really our solution based on the Siemens technology for asset performance excellence. And John, I think this will go back to you after this.
Yes, and I see we have some questions in the chat and so forth.
Okay.
Yeah. No, I'll get us started here, John. So I'm glad you said it, because I wanted to make sure that we were that we still had you. We didn't have any other issues. So, John, why don't we give Fabio a break for a second here and let him have a drink of water. So, in your presentation, you talked about the use of prescriptive analytics with smart energy. Do you have any real-world examples of what Engineering USA has done in this space, or what were the results of that prescriptive solution?
That's a question for Fabio, right, about Engineering USA?
Yeah. I'm sorry, Fabio.
Yeah. For you're talking about energy.
Yes.
Yeah. For example, I briefly mentioned in my presentation. So there was this case where the problem was of a company that wanted to optimize, minimizing the cost of energy, and we use really this application to monitor the energy consumption and the energy cost. So that was a case where the cost of energy was actually a variable, no? So it was an input for our data stream. So we basically build a solution where we could monitor the energy consumption and also the cost and the external condition in order to do a prediction on when the cost would increase, no? So out of that output, so the action was to move to solar, no? So in this particular case, no, was the possibility to switch to the local solar input. So we really use the data and and the decision process in order to decide, okay, when is optimal for me to switch to my solar producer. No? So this is something that before was done manually, no, or was done in a preventive way. So automatizing this process out of the decision, provide a big cost saving, no, to our customer.
Okay, perfect. Thank you. And everybody, excuse me, we see the questions still coming in, so that's great. John, this one looks like it's for you. So a lot of operations and maintenance is around asset integrity. There's a question around, can the Siemens solutions provide proactive or even predictive analysis around things like corrosion mitigation, coating failures, and related challenges? Any thoughts on that?
Well, yeah, I'm happy to. And what's interesting, it's while tangential, there's a question in the chat window that says, which software did you use to simulate the wind fluid dynamics? So when you're looking at the performance or the operations of assets, right, we've got, just to answer the question specifically in the chat, which is related to what you said, we do have a suite of tools which we've invested in, a company formerly known as CD Adapco, which is now our Sim Center suite here at Siemens, does a very good job at being able to simulate in detail with computational fluid dynamics your challenge in, say, wind fluid dynamics. But what's interesting is the suite is broad enough that if we want to look at corrosion propagation, right, holidays in coatings as those develop over time from degradation, we have the technology to do that. And here's the interesting thing, too. We've also invested in, and all these tools I talked about, these are all part of what engineering brings to the table as our partner. When you look, we have a tool called HEEDS, H-E-E-D-S, which is based on what we call the Sherpa algorithm. And what that does is that allows you to explore, if you will, your design space. You can parameterize all your variables. And then, if you will, it's almost, I think of it as almost an augmented intelligence as opposed to an artificial intelligence. It's your first step towards AI, where you remove your human bias from the analysis. And instead of looking at one or two or three different optimal or predictive scenarios, you start to look at several hundred, several thousand in the same time frame. And now, instead of looking at what you see as, to your question, John, the propagation of asset integrity issues, you start to look at several thousand cases of it, and you have an entire range of potential outcomes. So you can make better and more informed decisions in that regard. And we've seen this, John, you and I have actually experienced this kind of modeling in our training on HEEDS and working with customers and so forth. So I'm excited about the technologies that we have right now that we've invested in that allow a more intelligent, or in terms of what engineering says, a smart way of looking at asset integrity.
Excellent. Thanks, John. Fabio, is there anything you want to add to John's response prior to next question for you?
No, yes, I just, can you hear me? Yeah.
What?
Yeah, I just echo what John said. So yeah. Today we have the technology is ready now to have the capability to collect data out of the field. No? So through edge device, sensor, and all the things that you need there. No? So to have a solution that are able to start visualizing the data that are typically cloud solution today, no? But they are also the ones that can create models, no? So models to do prediction, so to start doing, okay, what if I do this, no? And this is really supporting the journey, no? So we have the capability to connect, the capability to store the data, and the capability to really using this data to support the journey. No, it's really a journey. It's not something that you go there, you install it, it works. Mm-hmm. No, but is something I need to create a plan to create the infrastructure through the products that are available today, no? And the fact that we have this cloud solution, edge technology, and AI technology supports the data journey for as we described. So this is very exciting.
Oh, it is. There's a lot of questions coming in, so I'm kind of combining some of the feeds here. We've got a question for you, Fabio, around around the availability of data. So when the availability of data is a big challenge, preventing doing the types of projects that you're talking about on your assets, how can companies overcome that?
Yeah, this is a very interesting question, no? Because in reality, when we talk about AI and machine learning, so the real challenge is not developing the model. So it's also a challenge, but it's typically not the biggest one. So the biggest one is really how we have a set of data that is ready to be analyzed, no? That is ready to be used to create this model, no? So here in engineering, we develop different approaches. On one side, so we have an assessment process. So we basically try to understand with the customer out of the data which are the methodology that can bring us to the final result in a shorter time. So we leverage the simulation tool. Not necessarily all this data has to come from the real world in step one. So we can start training the AI model through simulation. But we can simulate the process. We can simulate the machine, the asset. Now in the second webinar, so of this series, we really deep dive how we are going to use the digital twin in executable way. So that means we have the digital twin working together with the real world to also overcome this kind of challenge. So also to simulate the data in order to do the initial training of the AI. No? So I think this is a great question. Is a big topic. And is really the focus of what we do today, no? How to make all this overall process efficient. So.
Yeah. Okay. Okay. Good. And some questions coming in on the cloud as well. So, are the Smart 7 apps, are they available on cloud or on premise or both? You know, do you have any thoughts around the architecture and use at engineering?
No. Yeah. Of course. I mean, all these edge technology and cloud are both components of that, no? So and we use in combination. So for example, talking about the optimization and the decision process, typically, so the AI on cloud is fed by data in the training phase, no? But when we have the model that is identifying to support the decision, but we have the choice to leave this model on the cloud or to bring it on the edge, no, in order not to have the need every time to transfer all the data on the cloud. No? So, yeah, it really depends on the application. Of course, we want to leverage the cloud because that is a software as a services for all the advantage that bring to that, no, in terms of rollout speed, in terms of availability of the data, no? But also we can go to edge level when it's required. No?
Okay, great. And John, a question coming in for you on how the prescriptive analytics relate to the role that plays in terms related to the digital twin of an asset. Can you talk about how prescriptive analytics and the digital twin might support each other to help an owner operator in some part of the energy industry improve their operations?
Well, you know, as you guys were talking, I'll take that, but I'll take it in a different direction.
Sure.
when you're talking about prescriptive and so forth, what I also consider is the fact that there's a demand on good data orchestration, and there's a bit of a forensic capability you also need to have. For example, I was part of an investigative team back in, if memory serves, around 2008. There was an explosion in Northern California, if you remember, with PG&E. And we went out and we actually inspected the welds on the natural gas lines that had ruptured. And we found some crack propagation on those welds. And the interesting thing was, when we went back to start to understand, well, was this a material issue? Was it a weld procedure issue? Was it a welder issue? So you start to look at everything associated with that weld. There, at any one point, believe it or not, and it sounds like a large number, but there are 360 plus potential data points associated with any kind of weld. If you've done X-rays or ultrasonics, every time you did the root pass, and every time you created a data point or points around that weld, you have to collect all that data. Well, in our investigation, that data was very lacking, and being able to go back and forensically understand what caused that issue and where else might this issue exist in this natural gas network was almost impossible. So when we talk about predictive, John Lusty and Fabio, when we hear those words, I a lot of times also think about, well, we live in a world filled with humans and filled with imperfect systems. We're going to have challenges, both small and large. And so when you have these issues, part of your predictive or learning capability with AI is to go back and understand where you've had issues and bring those forward so you don't repeat the same mistakes. A big key effort in that is to have well-orchestrated, secure data. And so, while we have the analytics pieces, we have the computational fluid dynamics analysis capability. We have the 1D and the 3D simulation that we can use as analytics, and then contrast that against the sensor data or the SCADA data that you're getting from your operating asset-intensive facility, a wind farm, a solar farm, a chemical plant, whatever. But you also need to be able to contrast that against a well-orchestrated database, that you have the confidence in that information. So you've got your intelligent pieces, but you've got to have the data behind it, and you've got to understand that it's fully traceable. So for me, the better question is, do I feel that the data that I've got, that I'm basing my analysis on, is fully well-orchestrated and traceable? And that's the question you need to ask yourself and look at that business process, because there are real-world examples of where we've lost lives and lost assets and not been able to go back and fathom why. And when I say why, yeah, clearly we could see that the welds, ruptured. But the deeper questions of why did this happen and why those 5 whys that you ask yourself, that's got to be supported by data orchestration.
Okay, good.
Yeah, John, and what we are trying to do, is really combining so the data model with the what if model and the decision model in order to provide this orchestration. No? So it's not only the way of collecting data and put it somewhere, but it's also how we really leverage this data in together with the process information and the decision process in order to take the value out of that. No? And I think the technology today provide us the tools. No? So and these are the tools that we want to leverage really in the platform. So in this set of capability in order to support this data journey.
And Fabio, as you're talking, John Lusty, I noticed down in the Q&A session, somebody asked, are there ready-to-deploy apps? So Fabio, I think we should probably address that because in a twofold way. You've got your apps on the side with engineering. What I would do is I would say that a lot of times when people are looking for ready-to-deploy apps, there's still optimization of those apps or customization, if you will, that have to be done because, the challenges we have in the field are while they're common, they have their own unique flavors, if you will, with each customer. we've invested in a rapid application development platform called IndX, and engineering is one of our leaders in the deployment of that capability. And this is we knew as a very as a path going forward, and in this very nimble world where we've got to be able to address challenges, uniquely with each one, we couldn't come in monolithically and say, well, there's an app, but you have to conform to the way in which the app performs. No, you have unique business processes. You have unique challenges that, while what they have common elements, are unique to you as a client. So I would posit, take a look at our IndX platform, which you can download for free to practice with and so forth, and understand that you can take the business processes and the business challenges now, and in a low or no code way, drag and drop and create the apps that you need. And then when you need to add that real intense level of detail and data orchestration, you've got to really rethink, is this the best way to do this? Is this the most efficient way to run this business process? Well, then you've got engineering who can sit there and, as a partner, help you find the best way to gather said data, the best way to optimize those assets, and do it on our platform. Fabio, your thoughts?
Yeah, I mean, the smart apps are a starting point. So are based on the experience of the project that we have done. So, and when we implement a data journey, a program, so it's also very important to understand what is the quick win. No? So what we can, which kind of portion of the value we can deliver quickly. No? So, and here where the apps come into place. No? But I would say, yeah, it's just the beginning of the process. No? So, for example, I can start from the smart performance app and start measuring performance of my asset. You know? And this is typically a quick win. No? So, but I want to do that in an infrastructure that is allowing me to take the journey. No? So, and so what we typically do is analyzing the customer. No? So what are the quick wins? What is the journey, and which are the short-term goal and which are the long-term goal, in order to really support this journey and this value creation. No? So the answer is yes. So there are these are templates available and ready to be used and to be expanded out of that, not to the journey that is really kind of journey that is personalized customer by customer based on the business goals.
Good. And I know we're seeing in Western Canada, just adding to what you're saying, we're seeing a lot of uptake with companies that are running into challenges securing sufficient IT staff because of the big technology companies moving into the area, the Amazons and the Googles, which is making the owner-operators and energy utilities putting the squeeze on them getting the talent that they're looking for in the IT area. So what they're doing is they're adopting that Mendix capability, and they're really giving their knowledge workers the ability to develop their own apps and democratize that innovation, if you will, bring it forward. So very hot topic. Fabio, we're getting a lot of questions coming in. I think I'm sympathetic, being a former aqueous chemistry guy. A lot of questions coming in on the utility side, the water treatment side of power utility operations. Does Engineering USA have any capabilities that support this side? We haven't talked about this, so it may be a bit of an unfair question. But can you give any comments on the steam side of the equation?
No, yeah. We as a part of so our company, our group. So we have a division that is really focused on utilities, no, and the project associated to that, no. So
okay.
As in these days, we are really focused, for example, in US on maintenance of in the utility sector. So,
yep.
For example, what I showed before was related to, but this also connect to your previous comment, John. So,
yep.
the AR, augmented reality, is also helping the fact that maybe today I don't have the right person in the right place. No? So people want to stay home. Not
Yep.
so, and if I'm an expert, maybe I want to stay home more than someone that is younger than me. No? So, but the technology can help. So maybe today the expert of the plant not necessarily has to be physically located in the plant. If I have only one, I can now use AR. I can use this tool in order to support this extended collaboration. So I can use the expertise in a distributed way. So it grew a lot during COVID. It was kind of necessity at that time. So, but it's keep going. So, and back to, for example, for utilities, this is something we're quite big today. No? So we're really implementing this kind of solution in order to support all this maintenance process. No? So for the people in Canada, that have this problem is a common problem, guys. So, but we have some tools can help in that.
Okay, perfect. We did have some questions that were quite specific that we weren't able to get to, so we'll respond to them directly via email after the webinar. But Sarah, I think we're getting to the top of the hour, so we should probably leave you a couple of minutes to close things up as we bring this ship in for landing.
All right. Yes, that brings us right to the top. Thank you so much, John, for facilitating this Q&A. And thank you so much, Fabio and John Nixon, for your presentations today. We really appreciate you all being here. We would also like to thank our attendees for joining us. You will receive a follow-up email with a link to view the recording of today's session. So you can, of course, watch that again, and definitely do share that with your colleagues and higher-ups as you see fit. If you think of any additional questions or you need to request materials, you can email me directly at sarah.alspal@siemens.com. I can forward or point you in the right direction. You can also connect with me on LinkedIn, and feel free to always message me there as well. If you do have a project immediately in mind, you can go ahead and scan this QR code. This will take you to a list of phone numbers, so you can find the appropriate phone number for your location and get connected with a sales representative that can help you out today. I'll leave this up for just a moment, but I'll come back to it in just a moment as well. You can also find this link in the resources tab on the right-hand side, the resources widget, so you can be sure to bookmark that before you go. And this concludes today's webinar. Thank you so much for joining us, everyone, and enjoy the rest of your day.